Hi guys, welcome to the lecture series on data structure. This is Dr. Aarti, associated with Kamaraj College of Engineering Technology as an assistant professor in the Department of Information Technology. In the previous lecture video, we were discussing about the linear data structure with respect to Stack ADT, and we said this is a working with mechanism of last in first out, where the data that is inserted at the last will be deleted at the first. And we were discussing about the implementation of stack having with array and linked list, and in the previous video we have completed the array implementation of Stack ADT, and now we will be discussing about the linked list implementation of Stack ADT. But before we start the implementation, let us quickly recap about the linked list. So linked list, as we know, this is a representation of a node. So every linked list will be represented having with the concept of node, where node takes two parts. This is a data part and this is a part which is going to tell about the next address. So this is how any node can be represented. And speaking about its implementation, how this node is implemented. So this is nothing but having with two information. As we said, this node is nothing but having with two different information like 10 and null. So these are of two different data type. So in C, we will be using something called a struct, which is a structured concept. So struct node having with curly bracket. 10 is an integer value, so it is taken as int data, and then this specific part. So this specific part is nothing but again it is going to point to some other node. So for example, let us take a series of data. So this is going to have another node as 20, and this is again going to point to another node as 30. There ends. So this specific part is pointing to a node of its own kind. So we will be having the second variable of type struct node, and here this is going to be a pointer variable, and let me give the name as next. So this is called the structure definition. So whenever we go for a linked list implementation of Stack ADT, this structure definition is mandate, and this in data can be of any kind. You can even store a character or a floating point up to your application. So that depends upon the application. So in this case, we are going to consider an integer data. So it is as int data. So this structure definition has to be given initially. Now let us move into the linked list implementation, where we discussed about the Stack ADT in our previous video as push, pop, peek, isFull, SMT, search and traverse. So these are some of the operations that can be performed on the stack, and for the linked list implementation also we are going to consider all these things, right? So let us as usual start having with the isFull. Whether isFull operation can be done with linked list? No, it cannot be done. So this specific operation, that is isFull operation, cannot be done having with the linked list, because linked list is a dynamic memory allocation. It is allocated on demand. So we are not going to restrict that a list can be holded with so and so amount of data. We cannot restrict the limit for the linked list because it is dynamic. So isFull implementation cannot be done, but SMT, this can be performed, right? So how are we going to do SMT? So before looking into that, as we said, whenever we go for a linked list implementation, structure definition is required. There is a node definition is important. That is what we done in our previous step. The second thing that we are going to do is creation of a node. So we are going to do the creation. How this can be done? Using malloc. Whenever you are going to do any sort of insertion, this node creation is mandate. As of now, we are not going to see about any node creation, but anyhow, this node creation has to be kept in our mind when we go for a insertion operation, and then assigning of the node. So these are the two things that we will be doing whenever we start doing the insert operation. But let us now imagine that we have a node which is having the name as start. So to have this, just we will be writing as struct node star start. So this is how we will initiate your node, fine. And if we don't have any element in a stack, if a stack is empty, then it will be having just a variable like struct node star start equal to null. So this is how you will be initializing any node at the first level. What does this implies? This start node is as of now empty. You don't have any value, or it doesn't have any address. So that is why it is specified as null. It is not pointing to any of the node, or it is not having any value. So whenever we go for isEmpty checking, we could do this isEmpty checking having with if start equal to null. If start is null, then you could tell that print stack is empty. Since this is a pseudocode, I have mentioned as print, but if you are going to put into your actual code, this should be a printf statement if it is a C language, right? So for checking isEmpty, it is just enough to check whether start is null. If it is null, it means there is no data. And as I said, let me remind you once again, is full cannot be done because this is a dynamic memory. Now let us see about push operation. As you are familiar with push, so push operation is nothing but an insert operation. You are going to do some sort of insertion. So how this can be performed? As of now, as we said before, there is no data. If there is no data, your newly inserting element will be your first element. So looking into these steps, the first step is node creation. The second step is assigning the value. And third step is checking for isEmpty. Check isEmpty. If it is empty, if S, new node is the start node. If not, then traverse and insert the element at last. This is nothing but insert last. So these are the steps that we are going to do. How are we going to do? The first step is node creation. So just as you know, you are going to create a node using malloc function. So let me have a variable for new node as new node. So struct node star new node. So this is a variable which is going to represent a new node, and let me create that using malloc. So malloc of struct node star. So now my new node is ready. So this first step got over. So the second step is assign the value. To assign the value, let me have new node of data equal to element and new node of next equal to null. So this tells about assigning the value. Then we are going to check for isEmpty. So it is if isEmpty, we can call the isEmpty function, or else let me put the code directly here. If start equal to null. So this is telling about isEmpty. If it is isEmpty, then what I am telling, new node is a start node, that is start will be new node. Since this is one line of statement, I am not going to use curly bracket. If not, else, I am going to traverse. The entire list has to be traversed. So you know how to traverse. In order to traverse, I am supposed to have a temporary name. So struct node star temp equal to start. Now using this temporary name, let me traverse. So while temp of next not equal to null, temp equal to temp of next. So this will help to traverse the element. Once we traversed, so we have traversed. Once we traversed, we can insert the element. Now the temp is at the last. It is now quite simple for us to insert having with temp of next equal to new node. Now we have converted our algorithm into code by mapping each and every line. Now let us see how this is working. Let us take an example to do it. So initially it is telling that we are having a new node. So let me have a new node. So this is our new node. This is new node and new node of data equal to element. So this